All right, so let's get our Windows 11 computer set up for 64-bit assembly compiling. Now this guide assumes you've already installed Visual Studio. The Community Edition works fine. If you haven't installed that already, I've put a link down in the description. Pause the video, go and install that, and then come back. So the first thing that we need to do is we need to locate something called VCVARS64. This is a script that's going to give us an environment that we can compile assembly code in. It has access to the ML64 compiler that Visual Studio uses now. So where it is will completely depend on how you installed it. If you used all the standard installations and you installed a 64-bit Visual Studio on a 64-bit machine, it will most likely be under your local disk, your program files, your Microsoft Visual Studio, whatever year it is for the installation, then Community, if you installed Community, VC, your auxiliary tools, build, and you will find these batch scripts. Now you can see there's a couple here. There's the VCVARS32.bat. That will launch you into the 32-bit version. The 64 will launch you in the 64-bit version. We want the 64-bit version because we're doing 64-bit assembly. Next, we're going to want to make a shortcut for this. So we're going to right-click, show more options, and we're going to want to create a shortcut. Okay, and now that we have a shortcut, we are going to want to modify it just a tad. So first we're going to mess with the properties, and you're going to want to find this box that says target. So in this target, we are going to prefix this with command and then a \K. So what this is going to do is use the CMD terminal to launch this instead of just launching the batch script itself. And that's going to give us an environment we can launch into to compile with. And then you're probably going to want to change this start in folder. It is totally up to you. For me, I will be putting everything in a directory called playcode. For code that I am just playing around with. So I'm going to make this C/playcode. Okay. Now when we run this, that launched on the wrong screen. We have an environment that's been initialized for 64-bit computing, and if you type in ML64, you should see the assembler. And you won't have this in the directory yet, but you can download this from the GitHub and then test this. You can build our Fibonacci loop and then run it. Now you are all set up to compile assembly code. However, there are a couple of tools that we've borrowed from Randall Hyde to make this a little bit easier. Let's look at these three files right here. The first is, well, these two files, I suppose. The first is the general scaffolding of the C program that he's made. And then the batch file to build these. So essentially what happens is whenever we type build something, like we just typed build Fibonacci loop, this takes that first argument as a variable and then compiles the assembly and then goes on to compile that assembly with the C and link them together. And we then have a program that has the main function written in a different file, for example, like Fibonacci loop. And we have, we call that function, we call MASM main here. We have added a couple of things. We've imported or included our time functions, and we just do a little bit of profiling here. The start here, we are just essentially looking at what the time is right now. looking at what the time is when we finish, and then comparing the two to get how long this took to run. And you can see right here, this just gives us an idea as we start to improve our code, how much we improved or how much we worsened our code in terms of speed for performance. The C program that we will be using is on the GitHub as well, so you can just set up your directory to have the c.cpp program, the build.batch file, and then whatever your assembly code is as a .asm file, and that will be all you need to get started. And those I will link to the GitHub.